terms of carboxylic acids, the most important property, though, is to look at the acidity. As we saw previously, a number of these derivatives of carboxylic acids, especially when they've been deprotonated, are fairly important biological molecules. But in general, carboxylic acid hydrogens, specifically we're talking about this one, are very acidic. pKa ranges from about 0 to 5. And the one we've drawn here, which is our probably most well-known, most common carboxylic acid that we work with, acetic acid, has a pKa of 4.76. Now, just to put that in some perspective, an alkane, pKa of 55 to 60, alcohol, maybe 18 to 20, and that's one of the more acidic functional groups that we have out there. So, in comparison to an alcohol, very, very acidic. In comparison to something like HCl, much, much weaker. But, for an organic compound, carboxylic acids are about as acidic as they get. Now, there are other things within carboxylic acids that can influence how acidic they are. What are some of those things? Well, mainly it's the types of substituents we have on them. So acetic acid, we said, has a pKa of 4.76. What happens if we put a chlorine on there? Chlorine, we know, is an electron withdrawing group. And in general, electron withdrawing groups increase acidity. So the pKa of this compound, 2.86. So almost 100 times more acidic by adding that electronegative atom. And if we add another chlorine, as you would probably guess, the pKa goes down even further. And so in general, adding acidic functional groups, adding electron withdrawing groups, adding more electron withdrawing groups, and as many as we add, the better it is for the acidity of the carboxylic acid. Now, one of the important factors here becomes this. So as we start looking at long-chain carboxylic acids, these are what we would call fatty acids. Typically 10, 12, 14, 16, 18 carbons. Always an even number, but these are generally the fatty acids. Are fatty acids water soluble? No, we said previously that more than 4 carbons, generally a carboxylic acid is not water soluble. But what if we remove that acidic hydrogen and form a carboxylate salt? That will be water soluble. And when we get to reactions of esters in a little bit, we'll see a fairly important consequence of how these types of salts being water soluble can be very important for us.